So question 2, we're going to start off with just a simple demand and supply. And it's asking in equilibrium how many compact cars will be sold and what price. Pretty straightforward. Set quantity demanded of 1,000 minus 1/2 P equal to the quantity supplied, 350 plus 0.15 P. Collect terms. So we're going to end up with 650 is equal to 0.65 P, or P star is equal to 1,000. Now I can take that P and plug it back into either the demand or the supply. The demand looks a little bit easier to work with. So QD is equal to 1,000 minus 1/2 of P. P is 1,000. So Q star will be 500 units. So the next part of the question asks if there's an attempt to cap the quantity at 350. How much would consumers be willing to pay to prevent that cap from going into place? So we know the cap's binding, right? Because they actually want to buy 500. If you force it back to 350, that's going to cause some sadness. So the question is how much consumer surplus is lost. And the reason I know it's consumer surplus, so delta CS, the reason we're looking at consumer surplus is it's asking for a consumers association. So probably one of the better places to start is just by sketching out what consumer surplus looks like in the initial condition. So I'm going to have to find this upper intercept. The way I'm going to find that intercept is say QD is equal to 0. And that's going to be a function of the price. And it's going to be 1,000 minus 1/2 of P. So if you set the price high enough, demand will be 0. What P will actually drive demand equal to 0? Rearrange this, you get P, if you want to think of it as max, is 2,000. So that gives me the upper intercept. I also know from the previous equation where the market equilibrium is. It's at 1,500. So I'll just guess at where that is. 1, 2. Call it here. Price is 1,000. And we know Q related to the equilibrium is 500. We know the demand curve has to drive through that function or that point because it's part of there. So initially, before the change in the law, consumer surplus can be described as this big pink triangle. And the question is, what's going to happen to consumer surplus when you move to the new equilibrium? The one thing we know already is that the new equilibrium is going to be at 350 is going to be the quantity. So we can figure out what price consumers would pay in order to clear a market where there are only 350 units available. And the way we'll do that is we'll go back to the same equation again and say 350, that's the quantity we want demanded, is equal to 1,000 minus 1/2 of P. So 1/2 P is equal to 650. P is going to equal 1,300. So if this cap is put in place, consumer surplus will go from the pink triangle to the turquoise triangle. Sorry, I know the colors are bad. CS new. So all we have to do is figure out the area of those two triangles, subtract them, and that'll tell us how much consumer surplus was lost. So CS old is going to be 1/2 the base, 500, the height, 2,000 minus 1,000. That's going to give us consumer surplus equal to 250. Then if I want to figure out consumer surplus new, that's going to be 1/2. The base is now 350, and the height is now 2,000 minus 1,300. Or 122,500. So delta CS is going to equal the 250 minus the 122. So they're sadder under the new regime by 127,500. So they'd be willing to spend up to $127,500 to avoid the change in tax. Now I can scoot along to question number 4. Monopoly, single price, so pretty straightforward. We're just going to solve for optimal P, optimal Q under one-part pricing. We know we're going to set marginal revenue equal to marginal cost. To figure out marginal revenue, we'll have to come up with total revenue. Total revenue is going to equal P times Q. Since I know I need P, I'm going to do the inverse demand function of that. If I bring P all alone to one side, it's 1/4 P is equal to 6 minus Q. Multiply through by 4. Oh, that was pathetically ugly. I can fix that. The inverse demand function is going to be P is equal to 24 minus 4Q. I can then take that function and plug it in here, so now I'm good to go. So it's 24 minus 4Q price times quantity. That's going to give me 24Q minus 4Q squared. Marginal revenue equals D DQ total revenue. So the derivative of 24Q with respect to Q is 24 minus 8Q. So now I'm done with marginal revenue. I have to come up with marginal cost. That's D DQ total cost. Total cost, derivative of 15 is nothing. Derivative of 3Q is 3. So now I'm going to set marginal cost equal to 3 equal to marginal revenue, 24 less 8Q. Do a little bit of algebraic rearranging. 8Q is equal to 21. That's going to give me Q star is equal to 2.6 units. I have to figure out the price. In order to figure out price, I can go back into my inverse demand function up there in light blue. So P is equal to 24 minus 4 times Q. I know optimal Q is 2.6. So I feel like I've done an algebraic error. One sec. 6, 2, 5, 2, 6, 2, 5. So that's going to give me a price of 13.50 is my P star. So this is equilibrium P, equilibrium Q under one-part pricing. So the next part of the question asks, what happens if, whatever the store is, switches over to two-part pricing? using an upfront fee. And the rules for figuring out what I call fancy pricing is step 1, big pie. Step 2, eat pie. The big pie is telling you find competitive equilibrium, or set P equal to marginal cost, which is the same thing. And eat pie is charge fee equal to CS under competitive equilibrium. So first part's going to be pretty easy out of those two because we're going to look at setting price equal to marginal cost. Marginal cost we solved here. So we already know marginal cost is equal to 3, and that is going to equal P because that's the way you get through to a competitive equilibrium. Now I can figure out Q star by looking at how much consumers will demand based on a price of 3, and I know quantity demanded is equal to 6 minus 1 by 4 times P, or 3. So that's going to be 5 1/4 is going to be our Q star. Now, it usually makes sense to sketch out the graph. It's going to be kind of a trivial one, but we have to figure out how much, this upper intercept again is the first thing we have to look at. What price would you have to charge so that consumers would demand 0? So we're going to use the same equation as our QD. We're going to set QD equal to 0 equal to 6 minus 1 by 4 P. That's the same as saying P is equal to 24. So that upper intercept is 24. Demand function is downward sloping. I don't really care how accurate I sketch that. I know this line is marginal cost. That's equal to 3. It's given in the problem. That will also be price. So now I can figure out the equilibrium Q from that intersection is 5.25. So now I've defined everything that I need for consumer surplus. That'll go pink this time. So consumer surplus is going to equal 1/2. The base is 5.25 wide. The height is 24 less 3. So consumer surplus under the competitive equilibrium of price 3, Q 5.25 is going to give us $55.125. That's the amount of consumer surplus. And the reason I needed to figure out that consumer surplus that's the upfront fee that will be charged. So in order to run this warehouse club two-part pricing dealie, they're going to charge a price per unit of 3. They're going to sell 5.25 units, and they will charge a fee of $55.12.5. So that's it for part B. And the last part is part C, and, sorry, not last part, that was wishful thinking. What happens if there's a repair bill of $5? So it's not a recurring fee, it's just a one-time deal. So it's definitely not going to affect revenue. If it did anything, it's just going to change your total cost and push that up by $5. So your new total cost might temporarily be 20 plus 3Q. you'd still end up with the exact same marginal cost is equal to 3. So marginal cost is 3, even with that change. That means that the firm's not going to change the price. It doesn't affect consumers at all, so the quantity demanded won't shift. And the firm sets the fee equal to consumer surplus, so it won't affect either the price per unit or the upfront fee. It'll just impair their profits. The last piece is part D. We're finally getting there. And would a single consumer or this single consumer prefer a monopoly or two-part pricing? So the part that you're likely to get wrong is to think, wow, the consumer gets to buy more of this good. They go up to 5 1/4 units, which is definitely more than the initial 2 and change units. They're buying it at a much lower price of 3 instead of $13.50. So the consumer's got to be happier, buying more, lower price. So that part is true, but in order to walk out the door with that higher number of units, the consumer is stripped of all its consumer surplus. All of that gets transferred over to the monopolist under two-part pricing. So under two-part pricing, this consumer has 0 consumer surplus. And I'm not going to be very careful in the sketch, but it used to be $13.50, 2.65. Probably not the best color choice, but I'm running out of good ideas here. That's the old equilibrium under one-part monopoly pricing. And there, consumers at least get to keep. Now, I freely admit this is not an impressive amount of consumer surplus, but it sure is better than 0. So they actually would prefer one-part monopoly pricing, paying a higher price of 13.5 instead of 3, getting smaller number of units, shifting from 5.25 to 2.65, because at least they have some positive consumer surplus. Under one-part pricing, they have no consumer surplus under two-part pricing. So that is it for question 4.